So guys, in this video, all I did was build the circuit that you see here. So the thing that's different about this circuit is we've got 4 inputs and 2 outputs. We know the inputs in here are obviously 24 volt DC because the PLC generates 24 volts DC. And I've got 4 of them. I've got 2 series stops, 2 parallel starts. But notice that I've got the symbol for a transformer here, which is telling me I've got 24 volt portion of the control, and I've also got 120 volt above. So one of my outputs needs to be 24, and one of my outputs need to be 120. And this coil is understood to operate both of those contacts, which would then energize and do its job. The circuit itself is right here. So I built it to save a little bit of time. We did this in another one. All I did was use the branching mode, and I dropped 2 open contacts. So what you're looking at here is my first stop, my second stop, my first start, my second start. And we could label these down in digital inputs and digital output I/O objects. And we certainly could do that, and we will when we want to print these out in the future. But now you'll notice the important thing. Over here, it depends how your PLCs are wired in your lab. My Q0.0 is a 24 volt output. I made it that way. This output is wired for 120, and let me show you how. So you might remember from a previous video, if we scooch down in here, my Q0, my Q1, my Q2, and my Q3 are all 24 volts. But when I get over to my Q4, 5, and 6, I made those 120 volt by feeding the common on my PLC, which is right here. That common is 120. This common is fed with 24. So I'll give you a better layout when you see that in person. You have to be aware of that with your project. If you are in a different campus and all of your outputs are 24 volts, then you have to make them all 24 volts. It's not a big deal. It's just a matter of you programming the appropriate output. All of our stations here, if you can take a look here in Waterbury, all of our PLC stations, every single one of them are typical, which they're identical to each other, and they're all fed the same way. We've got 4 24 volt outputs and 3 120 volt outputs. Once again, you may have to make that adjustment. So how does that work for us? We put this in here and we are ready to transfer the circuit. Now, when we transfer the circuit, we have to understand that if you have this circuit in your PLC already, it's just going to look like it didn't transfer anything. The other thing I want to show you is wiring these inputs is a little bit different than motor controls. I took this red wire as 24 volt feed. I fed each screw on one side with 24 volts. So you see how there's 2 wires in there? Well, the feed comes into here and then it comes into the next stop. It comes out of this stop and goes into this start. It comes out of this start back through the trainer into this start. So all 4 buttons have the feed. And then my output, the other side of the switch, which would be going back as my inputs, are only 1 wire. So that's how you can tell that, you know, it's an easy way of knowing that. So you got to be aware of feeding those, and that's what our line-to-line paperwork is for. So when we look at our sheet, the connected dot sheet, once again, you'll get this in lab or in class. You got to connect these appropriately, exactly how it's supposed to be. So I would have these lines going like this. Notice I've got 1 line that leaves 12 volt or 24 volt DC. It actually comes over, if you trace it out with your eye really close, it feeds a stop, feeds a start, feeds a stop, feeds a start. And coming off the opposite screw of these goes back as your inputs. So if you draw it in there nice, it's pretty easy. So you got to be aware that these sheets have to get done. So let's go back and now transfer the program. Make sure your power is on, your control power and your PLC power. I am going to skip simulation because I want to get right to commissioning. Now you'll notice I got to click on this time, and I am actually plugged in and it's not showing anything because I'm already in. So in other words, let's stop the controller. I have this program already, so it's not seeing it, it's not allowing me to transfer. So let's go back to my program. Let's put the covers on the buttons because we need to see the closures in those contacts. So once again, the stops did their thing. They're closed, right? Just as they should be. And now I'm going to hit one of the start buttons. You can see I hit it. You momentarily kind of went green. Then the ceiling circuit took over. And now my 120 volt light is on. Remember, I made this 120, so if you remember the other labs, I didn't have any of these on. So my 120 volt light is on, 120 on. I've also got 120 volt outputs I could use with those. Remember, in this circuit, either stop button could stop the circuit. So I'm just gonna hit one of these stops. You can see which one I hit, and it killed the circuit. Either start button will energize it, so I'm going to hit a different start button. And once again, we got back to our circuit that turns on the light, and I'll show you in real time. Coil is still in the circuit. I'll hit this stop. I'll hit this start. I'll hit this stop. I'll hit this start. Either one will turn it on or either one will turn it off. Clearly see the PLC once again is showing the status of my output. Way over here, my Q0.4 is energized. That's my 120 volt output. Both stops on the input side, if you can see right here, it's the way it should be. If I hit one of them, I lose it. I lost my output. I'm going to release the stop button. That'll go back to being true like it should be, and I lost my light and the coil. So hopefully you enjoyed that, and we'll see you at the next video.